Well, thank you everybody for being here. Thanks for that really nice presentation, by the way. So again, yeah, my name is Paul Giancarlo. I'm a technical sales specialist for Autodesk. I've been working in Autodesk for 6 years now. To just so you know a little bit more about me, I come from the industry, so working as pipeline TD, visual effects TD, lighting TD. I did a bit of everything, but in my experience as pipeline TD, USD was one of the things that we were missing back then, so it really solves a lot of the issues in production, and I'm really happy to show you a little bit what USD is looking like today inside of Maya, Bifrost and Arnold. So as you might know, this has been a huge project for the last 4 years, and well, a lot of customers are very excited about this, and well, there have been several flavors of versions of this. So as you may know, Pixar and Pixel and Animal Logic, sorry. So the whole idea was to kind of put the two together into one. So what we're going to see today here, we're going to be building this stuff. So this city of machines, matrix. So it's a procedural node-based workflow. We're going to be seeing how to put together some modular USD prototypes, composition arcs, so variants, and also see in a non-destructive workflow. And we're going to be doing this based on an opinion-based layer system, so it's non-destructive. That's what we say. So the whole thing is going to be a lookdev layout, and rendering kind of workflow. So we're going to start first with a want module. So see how we export this stuff just as a single module with different variants or composition arcs instead of USD. Then we're going to put together a full tower using the same module, and that'll be very simple. I'll explain pretty quickly as I can. And then we build an entire city using scatter points, very simple tasks. So it's not very complicated, but it says you get a pretty good idea, what you can achieve now with USD instead of Maya. This is the final scene that I put together. So this is obviously using all the goods and the features inside of Maya. A little bit of the agenda, so we'll see. There's a huge to talk about, really, but we don't unfortunately have that much time. So we're going to see how to recreate, edit, load, and work with these USD inside of Maya. Then we're going to see how to author Material X using the new LookDevX environment or platform, which is actually looking great at the moment. Then we'll see some Maya Arnold USD plugin export, which is something new. That's actually quite exciting because it really allows you to save all this information inside of the USD container, so you don't lose any of this data. And finally, we'll see some of the USD inside of Bifrost, some procedural workflows. So I pre-recorded this because otherwise it would have been taking a long time. So I'm just going to go and play the video and explain on top the full process, right? So first we'll start exporting the Maya, the model as a USD model, and then we're going to import it back in different ways. You have to import USD and work with USD inside of Maya. So as it stands right now, you have your model. You can see it's in Maya intrinsic data. It looks gray in the outliner. When you export, you have here the USD export. It's as simple as that. If you scroll down, you see you have all these options, right? Over here. So you have the plugin export for Arnold. All you have to do is select that, and you're good to go. So you have the two options there for binary or ASCII. And it gives you a parent scope name. That's actually something you should input. It's quite important. And then when you do that, you have the ability to save geometry, stuff like subdivision surfaces and all that stuff. Not just materials, lights and all, but pretty much everything that it's built inside of the Arnold ecosystem. You can export as a USD preview surface, or you can use also Material X directly in the export here, which is quite nice. Obviously, you export that. And this is how you're going to be saving all the USD data in disk, so you can then confirm and start building your layout and your assemblies pretty much through a layer editor or whatever. As you see, there's two ways, so different ways. You can either create a USD stage from file, and they're just going to go find it. It's as simple as that. And you're good to go. So now you have your USD data inside of Maya. As you might see, it's living alongside with the USD, with the Maya data. Pretty much there. It's very fast. You can work with the USD in certain ways. I'll explain a little bit later the kind of things that you can do now. Another way you can import these data is through Bifrost. So you can create stages also through Bifrost now, which is a new procedural way to work with USD, which is quite great. So you can see it's pretty simple. You just add and create a new stage. So once you have the stage, you have on this right side, you will see you have a bunch of descriptions and things that it really explains to you how these nodes work, which is quite good. Let's see in grain. Now I want you to pay attention to the outliner. What happens when you connect this to the output? So first thing is to create an X form or define a primitive or a prim. At the moment, you see you create a proxy shape on this other side, which is what you're going to be seeing at the moment, so it's just a proxy. Make sure you have a shapes enabled, so you see all the contents that gets created over there. And once you create an output, you will see, now we have that proxy shape created on the outliner. And you will see when you create a definition prim, it goes by the name obj, which is just an object, pretty much. So all you have to do is just grab that and change that to whatever. So in this case, we're going to be creating an asset, so it's going to be called pod, for example. And this is pretty much the same path that we're going to be using later in order to create the tower. So it's going to be used as a print path later in the talk. So a good thing about this now is you can go find your reference, put it in layers, and then you have already a non-destructive way to work with this USD material inside of Bifrost. So you can make changes inside of Maya, re-export, resave, and next time you load in Bifrost, you'll get all those changes in. All right. So another way you can also get this into USD form is directly creating an empty layer. So you see you have the USD, we have an anonymous layer created, and it's fairly simple. So you can select whatever you want to put as a USD data and send it to the stage. So in this case, you can right-click, and you see I'm going to send it to that particular stage. Just the typical Maya way. So I guess what the team is trying to do is that you work in an environment that you're used to, so you don't have to kind of learn new ways of work with USD, so inside of Maya, so which is quite nice. You have your typical operations where you can isolate an object, you can move stuff around, you can rotate stuff around, but you can see I'm actually adding one by one. Whenever I do this, I'm losing materials, I'm losing all my shading information, so I'm only sending a model to the stage. I'm doing this so then I can later use LookDevX in order to then create some shaders or import some Material X that I already have in library and then use those. You can see whenever you do this on the outliner, everything that looks in blue, it means that it's foreign data, which is USD data, but it's also living alongside with the Maya data, which is a pretty good feature. At this point in time, you actually don't need to have the Maya file or the Maya data there in the Maya file anymore. You can delete it, hide it, or do whatever you want. As you can see in USD, I'm just performing your typical operations, like rotate to the channel box, do your typical operations. But if I needed to do something more, I can edit as Maya. That creates a node at the end of just a kind of selection set, which holds this information. That's being shared in memory at the moment, so that's why I can perform all these changes, so I can change stuff, I can edit stuff around, and do what I would typically do inside of Maya, like work normally. And once you're ready, so your typical, day-to-day, like align stuff, move stuff, change stuff, edit stuff, add textures, do whatever you want. But in this case, we're only taking care of the model. So once you're ready, you just need to merge it back, and you're pretty much ready to go. Now you have a USD object you can start using through the pipe. You can send it to your texture artist. If you have some sort of animation, you can send it to the animation artist as well. The animation part will work a little bit different, but at least you have a USD object that you can work with. You can add snap align at the moment, so there's a lot of functionality that is working inside of Maya that you can do directly as USD data, which is quite good. So now let's see a little bit about LookDevX. This is a new project that is still in beta, but it really adds to the pipeline, and completing the whole idea of working with USD. So at this very moment, the way it looks, it's pretty much like Bifrost, so it's a VNN. It's a visual programming environment, a visual node network. So in this case, I pretty much just did the same thing, and I just exported the entire hierarchy as USD. As you see there, I'm just going to add it. So I don't have to add one by one. I can add the entire hierarchy, and it will, go exactly the same in respecting pretty much every single hierarchy that exists. So at this point, you could either save already in disk, so you can, be sure they're always working on a file that already exists on disk. Feel free to stop me and ask any questions at any point, right? So whatever you want to know, if there's something, any doubt, just let me know. So in this case, it's your typical Maya way. So you're going to save your file, you're going to save it as USD. So next thing to do is just add a shader. So through LookDevX, you can do that. So now you have the LookDev environment over here. You can create your nodes, pretty much. So you can really right-click and assign a new particular shader. You have the USD preview surface or Material X. As you might see, you have the shader surface, preview surface, ULTX, and AS standard surface as well, if you want to. So in this case, we're going to just create a new standard surface, which give you a definition scope, which is a look definition scope, which is quite nice. So you see you have your compound there. You can change stuff on this side of the window. And if you click on the actual shader, you can also use the attribute editor on the right, which is quite nice. So you have both environments as well, so which is quite good. Now you can start, editing and changing stuff like you normally would do through your attribute editor, which is quite nice. So changing colors, adjusting parameters like opacities, etc. So in this case, I'm adding some specular reflections and such. I'm gonna put my glasses on because I need to admit I don't see anything without them. There you go. So as you can see, so your normal look dev, you can work, change stuff, and you get your viewport updated because we're using the Arnold render in the viewport. So you would normally work the same way you always do. So which is a good thing, for my artists who actually used to work, in this same way. But if you're happy, you can always obviously use your LookDevX environment, which is what we're going to see at the moment. So another way you can bring in stuff, you can import pretty much the Material X that you already have in library. So all you have to do is create a new definition. In this case, I'm going to add a look, our scope for material scope, and just reference in that particular material that exists already in disk. So this is quite nice because in any pipeline you can define different shaders, and then you can attach them procedurally. You can attach them in any particular way that it fits your pipeline. So in this case, I just bring a specific material. As you can see, it brings all the definitions over there, and I can graph it. So at the moment when you graph it, you can go in and see the contents of this particular compound where all the connections are being made. So you can always explode. And the good thing now is that even if you have this build, you can again go into the deeper level and start adjusting things. Like add in saturations, or add in any type of shaders that you want, or modifications to your shader. So in this case, in order to apply that specific shader, it's very simple. I just select the entire hierarchy where I want to add that to, and it just assigned the shader or the material to the particular selection. And you can see you have an instant feedback there in the viewport, which is quite nice. So one of the things is, okay, since you're working and you have a kind of good representation on the viewport, it really facilitates the way for LookDev's artists to kind of move a little bit faster. So as you can see, the representation of the viewport is not too far off from the actual final render. So one thing that I might want to do now is like maybe I want to add a desaturate node or do whatever I want with this. So that's kind of a very simple thing. As you might see, you have all the nodes that you would need. In the same way, you would access them through the tab menu, or right-click and just go find any of the nodes that you want to use. In this case, I'm just going to be using a simple desaturate node. I'm not sure if I can offer this, but maybe somebody would like to be part of the beta. Is that possible? Yeah. So if anyone would like to test, this technology, it's actually, great for the team. I'm pretty sure. So get some feedback from some of you. It's great stuff. So as you can see now, this case I'm just desaturating stuff, doing my changes. At the very moment I have to kind of go through a script in order to update the viewport, but that'll be changed automatically later. But that's it. Now, yeah, you kind of get an idea. So now we have a build, the dark shading network. You see I have my pod with all the shaders applied. You see I have some shaders that I apply myself through the LookDevX environment and have some other shaders that are imported in using different libraries. In this case, I use the AMD library for some of them. So I have a full object with everything applied to, and all I want to do now is test it out, right? So next thing would be to maybe export this, save it out, and maybe take it into Houdini, try to render it with Mantra, right? We have nothing to do with Arnold and Maya in general. I don't think this is actually playing. Sorry. There. Oh, one thing I wanted to show you is that, one thing that I noticed, and I guess everyone would be worried about, how can I change stuff like adjust UVs after the fact? So that's something you can actually do. So same way we did before, just going to add a edited Maya, and when you do that, you see you kind of lose your textures for a second, which is not a big issue. Like you can perform your typical tasks. Like in this case, we're going to add a planar UV map, which is very simple. Then I'm going to merge it back into USD. And voila. So you got your UVs are being fixed. You're still working in USD. You want to ask a question? No? Do I have 5 minutes only? Can I get a little bit more? Really? Okay, it's just because I haven't. Okay, I'll be very fast then. Let me move faster then. Okay, so the next step, and I'll try to, move as fast as possible, is now to build your composition arcs. So now, say you have 3 or 5 different versions of this particular part or this particular model with different textures or lighting setups, whatever. You export them all as USD. You have them on disk, and now the next thing to do is just create these composition arcs that we call variants. So that's doable very simply through Bifrost and procedurally. So pretty much the same thing we did before. We connect, and let me see if you can go a little bit faster without crashing this. Oh my God. Sorry, it's the PowerPoint won't let me do it like that. Maybe I need to open it up in... I'll do one variant, and then we move on, right? So I don't want to show you the entire thing because we don't have any time. But I'll do one variant, and then we'll move on to how to build a tower out of this, and then maybe if we have time, how to build an entire city. But it's quite simple. So if you right-click, you have access to a bunch of different things. So you can define a specific variant definition. In this case, because I'm working on a specific asset, I'm going to call this as an asset. So, and I'll explain why later, because this is also the way we're going to purpose the asset. So you have a proxy version that works in the viewport, so you can get your memory optimized, and then you have a full render version. So that's kind of the default. You also have set up to proxy. So one thing you want to make sure is to turn on render. So when you import your very first one, you'll still see it on screen. But if you specify then the purpose is a proxy, it'll always show you the proxy anyways. Things what you want to do is now when you define a variant set, just give it a name. It's as simple as that. Just put the name and have a very first selection. So what's the very first object you want to select? Next thing is just create a children. And when I create a children, we want this to leave, to be the basically children of this particular object, which is the asset. And at this level, you can have 20, 30 different children, which are different variants of the same assets. So basically, this is what you're building. And then obviously you can call them from, you can randomly select which one you want to use to populate your modular tower or whatever you want, which is quite nice. As you can see, as I do this, in the outliner you will see, now you get a kind of a V icon there. This is kind of telling you there is a variant set existing there. And now you have the ability to select, the variant set, right? Okay. I'm going to move on. So there's basically you do the same. Now you just go find the reference that you want to use on disk. And that's pretty much it. Now you can just pretty much copy and paste this one, bring as many as you want, make it a compound, be free to do whatever you need to do in this case, right? So just to explain pretty quickly how you specify whether it's going to be a proxy purpose or final render. When you go into the main prim object, You can specify there in the kind, if I can stop that. In the kind, you can specify here whether it's going to be proxy or render. And that's all you need to do. So now you have another children, then you specify this is going to be the proxy, and then Maya will exactly know which one to display depending, what you select in the outliner, in the attribute editor. So next thing is go, okay, how do I now procedurally build a tower out of just one module, one particular one? And this part is actually kind of amazing. It's very simple to do. We're going to be using some construct points, and we're going to specify how to build this with this compound that already exists. This compound was built with one of our colleagues, his name is Guillaume Laforge, but I can share it with you if you're happy. We have this in the YouTube channel, Maya Learning channel on YouTube. So if you want to get access to these assets, just write through there. So you can pretty much send an email to me, and I'll make sure that I'll get all these assets so you understand how these compounds work. They're quite simple, to be honest. I wish I could move a little bit faster. But in this case, I'm just building just a new prototype for this. So it's literally just a point instancer node that we're going to get from here. But first, and it jumps all the way back down. Let me get it closer. Okay, as you can see, there's one thing that's called prototype definitions. First, I'm going to specify the points, which is this specific node that I've already have built as a compound. And then for the prototype definitions, I'm going to use the prim path of the object that I already created that has all these variants. So all I need to do for that is just, same as I did before, just give it a name just to be sure, Maya knows exactly where to find stuff, or Bifrost. In this case, it's going to be called a tower. So, and this is the same prim that we're going to use then to build the entire city. And this is the prim path. It's as simple as just specifying in here. Instead of loading a layer, you don't have to go and export this yet. You can just use whatever you built instead of Bifrost. So this is quite nice. So all you need to do is just create a new prim path and give it a value. And the value is just a copy paste of the prim that you created before. So pretty much just put asset. So I'm just going to copy that, input in here, and now you're good to go. Now you just procedurally build an entire tower out of just the same prim path. So it's quite nice. I wish I could explode it and go in, but basically what this compound is doing is calculating the distance between the origin and where the pod is sitting in space. And then it's using a pi node to go around and then build an entire full section, and then same thing to go up. So just a multiplier exercise. And finally, for the city, it's going to be pretty much the same thing. So we're doing here really is taking the same thing that we had before, so the same tower that we built, and now we're going to use the same point instancer, but instead of using some construct points, we use just a regular simple scatter point. So on the scatter point, it's just going to specify same path, so same kind of thing we did before. So we're going to use the path of the tower that we defined before, that particular prototype, and then from there we can build an entire city that we can change. We can adjust, the amount of the pots that we want, and the square friends, and how high you want them to be, and it's all kind of really nice way to procedurally build your environments using Bifrost. So I'll leave it play because we only have time for questions now. So just if you have questions now, I'll just watch the video or ask me questions. My channel, my channel is actually we have to go through the Maya Learning channel. So if you go through the Maya Learning channel in Autodesk, you will find this video, right? And just send an email so you have access. You can ask them to send an email to me so you can get the assets. Yeah. Yeah, I do have a channel. It's called JPG. JPG. Yeah, it was Autodesk World, but now it's just if you look me up on YouTube, you will find my channel. It's Paul Giancarlo. Yeah, used to be Autodesk World. Now it's it's JPG, just like Paul Giancarlo, which is my name. Yeah.
I also have another question. researching like a couple of months ago about Bifrost, and I didn't had any. N- n- well, there weren't that much tutorials necessarily on the Bifrost itself, and I tried to specify the difference between the Bisoft multiplier and the mesh one, because I had like a huge project that kept on crashing, and all of a sudden from that planar projection of mesh, I started using Bifrost because it kept on crashing because of the iterations. And I just wanted to ask, maybe I caught like from the beginning of what is it used for and why is it useful so much, the Bifrost as itself.
Bifrost in general,
Yes.
to me, well, Bifrost have a lot of uses nowadays, so it's not just for simulation anymore. So there's a lot of good uses for it now. I also have a lot more solvers like Aero Solver, NPM Solver. You also have the raycast nodes where you can use it for a lot of pretty good things. So one good case that I can think of is one of my customers in Europe, in Spain. They were pretty much rendering every single scene just to find interpenetration between characters as an ambient occlusion path. So they were really wasting time there. So it's a good efficient pipeline would be to use the raycast node just to find those interpenetrations and see, just pretty much here's a problem, there's a problem, and that's a very, very fast way to do it. So there's a lot of pretty good uses. You can also build environments procedurally, like this is what I'm doing here. You can do it without USD, you can do it with USD. I would recommend USD because of all these advantages. Now you have, access to composition arcs, variants and such. So, and not just to build stuff, but also lightning sets, for example. So say you have a set, whether you have a bed which is homemade, and then the same bed which is made, or night setup, day setup. You can use these composition arcs in order to set that up. So there's a lot of infinite uses for USD, not just what you just saw here. This is just a really nice use case, a very simple one. You're welcome.
I'm so sorry. We actually kind of have to close a little bit without the Q&A section, considering that we let the man talk a little bit more. He's going to be waiting for
Can
you.
we have him just ask his question? It's just one last question.
All right, you got it, sir. All right, for you. Oh, okay.
Yeah, thanks. I was just going to answer the question a little bit more. So you're asking kind of what is Bifrost, what is it for? So it's really about general proceduralism. So it is a programming language that's kind of within Maya, but it runs kind of outside of Maya as well. And hearing you talk about, oh, it was crashing or I had this thing, that actually is both an advantage and a disadvantage. What probably happened in your case is that you had an iteration that just never terminated. So you ended up using all memory and then the computer crashes, you have no choice. And that kind of points to your second question was, how do I learn this? And so when Bifrost came out, we didn't have a ton of learning material, but now we do. We have a lot. So if you go to the My Learning channel that JP was talking about earlier, I think every 2 weeks there's a new video going up. We have a bunch of series of videos that show kind of the basics of visual programming and kind of moving on through all those things with very simple things that you can kind of start to wrap your brain around it, and then you can go crazy with it.
Started, but it was too different from the workflow that I used to do with everything that Maya had to offer before.
Absolutely. It's more of a programming workflow, which is kind of that procedural mindset, but that is super powerful. So once you wrap your brain around it, you're going to see you can do really amazing things.
Thank you.
And thank you, sir, for helping
Thank
out.
you, Eric. Yeah.
We have to prepare for the next panel, so I'm going to say thank you again for your time. And we're sorry about the technical difficulties.
That's all right. All right. Thank you, everybody.